Hi, mathletes! Today we're going to be investigating the sum of the exterior angles of a polygon. Do you ever wonder what happens when you walk around a polygon? Well, in today's video, we'll explore exterior angles, those sharp turns on the outside of each vertex. You will be learning how to calculate exterior angles in any polygon, why they always add up to 360 degrees, how to find missing values using angle rules and formulas. For the sum of the interior angles, please watch the video that I did previously. You can just use the QR code. And the information in that video is really important because we use what we learned in that video in this video. So let's investigate the sum of exterior angles of a polygon, and let's organize it in a table. So we'll have the polygon, a diagram, the sum of both the interior and exterior angles at all the vertices, the sum of just the interior angles of the polygon, and then the sum of the exterior angles. And we'll calculate that by looking at the third column, which is the sum of both, and we're going to subtract the sum of the interior angles. So let's start with our quadrilateral. Then we'll have a pentagon. After that, we'll have a heptagon. And then we'll end with an n-gon, which is any sided figure. So here's my quadrilateral, and I extended the sides so that you could see the exterior angles. The exterior angles are in red. There are even numbers, angle 2, 4, 6, and 8. The blue are my interior angles, my odd numbers, 1, 3, 5, and 7. So to find the sum of all of the interior and exterior angles, I can add angle 1 and angle 2, and I notice that they make a straight line. So a straight angle is 180 degrees. I also notice that 3 and 4 are supplementary, so they also equal 180 degrees. 5 and 6 are 180 degrees, and 7, 8 are 180 degrees. So I have 4 straight angles, so the product of 4 and 180 degrees is 720 degrees. So all of the angles, both interior and exterior, add up to 720 degrees. Now let's figure out the sum of the interior angles. Again, they are our blue angles, 1, 3, 5, and 7. And this one comes from the previous video that I mentioned about finding the sum of interior angles. And in that video, we realized that it's the number of sides minus 2 multiplied by the degrees in the triangle. So we know that every triangle is 180 degrees. This has 4 sides, so we subtract 2, so the difference is 2. And the product of 2 and 180 degrees is 360 degrees. Now we're going to find the sum of the exterior angles. And we're going to look at these angles, angles 2, 4, 6, and 8. So we want to know what they add up to. So what we do is we're going to look at the sum of both, which is 720 degrees. And then we subtract the sum of the interior, and that will be what's left is the exterior, which is 360 degrees. Now let's try the pentagon. And again, I extended so you could see that we have our exterior angles being in red again and the interior being blue. If I add them up, I get 5 exterior and interior angles making supplementary angles. So 1 and 2, 3 and 4, 5 and 6, 7, 8, and 9 and 10. So the product of 5 and 180 degrees is 900 degrees. The sum of the interior angles, the number of sides, so there's 5 sides, minus 2, which is 3. And the product of 3 and 180 degrees is 540 degrees. Now we can find the difference. 900 minus 540, 360 degrees again. That's interesting. Let's try the heptagon. Okay, here's my heptagon. And it has 7 straight angles because it has 7 sides. And the product of 7 and 180 is 1,260. For the sum of the interior, again, it has 7 sides, minus 2 is 5. And the product of 5 and 180 degrees is 900 degrees. So now we find the difference, and it's 360 degrees again. I see a pattern going on. Let's try the n-gon. So it could have any number of sides. So we're just going to make n equal the number of sides. So if n equals the number of sides, I can say n multiplied by 180, just like I said 7 multiplied by 180. In algebra, we usually write it as 180n. And I know that the sum of the interior angles is the number of sides. So again, n minus 2 multiplied by 180. So with the distributive property, I'd have 180 degrees n minus 360 degrees. And now we're going to find the difference. 180n minus 180n minus 360. And now I'm going to use the distributive property again, and I get 180n minus 180 degrees n plus, because a negative multiplied by a negative is a positive, 360 degrees, and I end up with 360 degrees again. So now let's use our knowledge about the sums of interior and exterior angles. So let's say we have a regular nonagon, 9 sides. Let's find the measure of each exterior angle. Let's see what we know first. Well, we know that the sum of the exterior angles of all polygons is 360 degrees. We just showed that in our table. We also know that a regular polygon has equal sides and equal angles. So therefore, I can take my 360 degrees, divide it by 9, and get 40 degrees. So in a regular nonagon, each exterior angle is 40 degrees. But what would be the measure of the interior angle of that same nonagon? Again, what do we know? Well, we know that if we add the exterior and the interior angle, the sum is 180 degrees. And we already know that the exterior angle is 40 degrees. So I just have to find the difference. 180 minus 40 is 140 degrees. So that means in a regular nonagon, each interior angle is 140 degrees. Now let's say if each interior angle of a regular polygon is 144 degrees, let's find the exterior angle. So again, what do we know? We know a regular polygon has equal sides and equal angles. We know that if we add the interior and exterior angle, they equal 180 degrees. And we know that the interior angle is 144 degrees. That was given in our problem. So now I need to subtract 180 minus 144 degrees. And that means each exterior angle in this polygon is 36 degrees. Well, if we know that, maybe we can figure out how many sides this polygon has. Again, what do we know? Well, we know that the sum of the exterior angles in any polygon equals 360 degrees. And we know that each exterior angle is 36 degrees. So if I divide 360 by 36, I get 10. So that means it's a decagon, or a 10-sided polygon. Okay, let's look at this one. This is a pentagon, and it looks like it's extended to make a 5-pointed star. And what I want to know is what's the angle here at the point of the star? So what do I know? I know that the sum of the interior angles equals the number of sides minus 2 multiplied by 180 degrees. So let's look at this pentagon. The pentagon has 5 sides, so 5 minus 2 is 3, multiplied by 180 degrees is 540 degrees. So that means the sum of all these interior angles is 540 degrees. I also know that each interior angle is the sum of the interior angles divided by the number of sides. So, since it has 5 sides, angle 1 would have to be the quotient of 540 divided by 5, which is 108 degrees. So I'm going to duplicate the star below, and I changed the number 1 into 108 degrees. So we know this is 108 degrees. I also know that if I add the interior and the exterior angle, they equal 180 degrees. In other words, they're supplementary. So that means if I add angle 1 and angle 2, it's 180 degrees. I know that angle 1 is 108 degrees, so I subtract that from 180. That means angle 2 must be 72 degrees. I also know that all angles are equal in regular polygons. Therefore, angle 1 has to be the same as angle 3. So if angle 1 is 108 degrees, angle 3 also is 108 degrees. I also know that angle 2 and angle 4 have to equal each other because they are supplementary angles to angle 1 and angle 3. See, angle 1 and angle 2 were supplementary, and angle 3 and angle 4 are supplementary. And if angle 1 equals angle 3, then angle 2 must equal angle 4. Therefore, angle 4 has to equal 72 degrees. All we have left now is x. Well, I know that the sum of all the interior angles is 180 degrees. And I know that if I add angle 2, angle 4, and angle x, I'll have 180. I know that angle 2 is 72 degrees and angle 4 is also 72 degrees, which is 144 degrees. I subtract that, and that means that angle x is 36 degrees. So the angle at the point of the star is 36 degrees. So here's some takeaways from today's video. The sum of the exterior angles in any polygon is always 360 degrees, no matter how many sides it has. In regular polygons, each angle can be found by dividing 360 degrees by the number of sides. And you can use the relationship between interior and exterior angles, they're supplementary, to solve for unknowns. So now you can confidently tackle polygons from any angle. You've come full circle. If you like this video, please click like on my video. And better yet, if you haven't already, please subscribe. I would love that. And as always, thank you so much for watching.